Okay, thank you. And thanks to Caddy for having me here. I'm really happy to come and visit with you guys and learn about what you're doing. It's all really fascinating. I'm Michael McLennan. I'm from Purdue University. I'm the director of this HUBzero project. And I wanted to tell you a little bit about HUBzero and kind of how people are using it to connect to data and tools and to each other. So first of all, what is HUBzero? It's an open source software platform that we put out. We developed at Purdue over the last decade or so, and people use it to create websites for science. So for research, for education, and for collaborating online. And some people call those kinds of sites collaboratories or science gateways. We just call them hubs because they kind of tend to be a focal point for a community to kind of work together online. So that's basically what it is. It's web software to build these kind of websites, you know, kind of a word. I gave a talk once, somebody said it's like a WordPress blog on steroids or something, a lot of steroids. But the best way really for me to explain it is to show you kind of a video of what it is. So hopefully this will work okay on the monitors without making the video card crazy. All right. So this is the world of HUBzero. Again, people all over the world are using these websites. So photorealistically generated users, just like this one, sitting in their living rooms, accessing all of these various sites depending on what they're interested in. So there's a site, for example, for nanotechnology, the original nanoHUB. There's one for earthquake mitigation, where they're shaking buildings and seeing how they fall apart. For pharmaceutical manufacturing, for molecular diagnostics, and so forth. So these are all the different hubs that people have built using that same HUBzero software stack. They all work the same way, but they're all different communities. There are more than 60 of these now running all around the world, and if you put them all together, they serve more than 1.8 million people each year. So let me show you what these people are doing. We'll start with a group at Penn State. This is a group that wanted to be able to put up a tool for an online class. So they went to nanoHUB and they started resources upload. And of course, if you're going to contribute something to a hub, you have to have an account and log in. You can sign in with Google or Facebook or register an account. So they logged in. If they click Get Started, then it asks them what they want to upload. Is it a seminar or a paper or, in this case, a tool? So they filled out the form for a tool. Just give it a short name, who's on the team, whether or not it's open source, and all of that. So filling out this form creates a project area and a Subversion source code repository that you can work in and work on your tool. It also gives you access to something that we have called a workspace, which is kind of a Linux desktop that runs in the cloud. And it has all of the software for the hub kind of pre-installed, and it gives you access to clusters and all of that. So you can get into a workspace and you can make your tool run and then deploy it. And you can put anything in here. You can use MATLAB, Java, Qt, whatever your favorite programming language is. If it runs under Linux, it's good. But a lot of people come to us and say, well, I've got this old Fortran program that's kind of written for the command line, or an old C program. And so this Rapture toolkit that you're seeing here is a really easy way to create a graphical user interface for those old programs. So you drag and drop a couple of number controls, and you say it produces a curve, and you annotate it with a label and description and units. Here I'm adding a note, a little bit of HTML documentation to the tool. And again, I can preview the tool and see now this is what my tool is going to look like. 2 numbers on the left produces a curve on the right. So I'm in pretty good shape of creating my tool here with drag and drop. I can also go in and say what language I'm targeting, in this case Python. And when I go ahead and save it now, it'll save 2 things. It'll save an XML description of the inputs and outputs for the tool, and it'll also create a skeleton program for my Python program. So I'm saving those 2 things, and if I go in now and edit my Python program, there's all the gobbledygook that Rapture adds automatically for the inputs and outputs that you defined, and then there's a comment that says add your code here. So you just go in then, right there, and add your Python code for the simulator using the numbers on the input side, producing outputs on the output side. So here's the finished tool. You fill in a couple of number values, you click simulate, it goes off and runs that Python program that we just looked at. So that's how it works. And then we have a framework for deploying that tool. So in this framework, kind of a content management system, you can click Launch Tool, and it'll pop up the tool and kind of preview it for you so you can see what it's going to look like when it's finally published. And then there's a link that says my tool is working properly. And you click that, and it gets published. So for this tool, there was a user in the UK that was actually fabricating nanospheres in the laboratory, and he went to nanoHUB and was searching around for stuff. extinction efficiencies and scattering and so forth, and found a lot of stuff, seminars, questions, all kinds of things on the hub, but most importantly, that tool that the Penn State group put up. And you can see there's like 600 people using the tool. It's been used in class, a couple of citations, but you can just run the tool just by clicking Launch Tool. So this is what the guy in UK did. He clicked Launch Tool. This is a more complicated version of the simple thing that I was showing you, I was building. But same idea, you fill in some values, you get a plot, you can change material types, simulate again. So here I've got 3 different kinds of materials for the nanospheres, and you can see their kind of optical properties. I can look at absorption or scattering, I can zoom in on the plots, I can mouse over values, find an interesting peak, what's the wavelength of that. And then I can also download all of that stuff to my desktop. So when I click download, it'll download all the data that I generated from those simulations, and I can save it, put it in my own spreadsheets and plot it. And that's exactly what this guy did. In fact, he ended up writing a paper about this, about the results on nanoHUB and his experimental results. So changing gears, here's another application. The researcher at Purdue who was doing an agriculture study. And she went to this Purdue University research repository. This is Purdue's institutional data management solution built on HUBzero. So it's basically another hub that does data management. And she logged in. She created a project area for her project. So maize grain yields, again, agriculture application. And if you want to describe the project, you can add a little bit of an abstract. So if somebody sees the project, they'll know what the heck it is. Oh yeah, this is that one that Sylvie created for the maize grain yields. You can add an icon. If you have about 50 projects, it really helps to have icons so you can recognize at a glance which project is which. And there's some controls too. You can say whether or not the project is visible to anyone or whether you want to keep it completely hidden. So the only way you can get into it or know about it is if you're invited in. But at least if it's visible, then people can see the abstract. They still can't get into the data unless they're on the project team. Now that's what we're doing here. We're adding people onto the project team, inviting them in. And if you start typing someone's name, it brings it up, but you can also just put in their email address, and it'll send out an email invitation and invite them in to the hub. So all right, now I've got my team, a few people added in. I can always add more later. I click Save and Continue. One more thing that PUR does in particular, it asks information about the project that the sponsored program office can use to make sure that people are actually following their data management plan. So this ties into our kind of university administration. So here's the final project now. It has a kind of a Facebook-style wall so that when you come into the project, you can put up messages and people on the project can kind of converse on the update wall. It also has a file repository that you're seeing here. This is kind of like Dropbox or something like Google Docs or Google Drive. You can upload your stuff in it. Under the hood, it's a Git repository. So we're actually doing version document control, whether people know it or not. But there's a whole web interface that makes it super easy to upload your data. So here, I'm uploading a zip file. I can expand it, and it'll expand the zip, and it gives me all kinds of stuff that I can browse around. So anybody on the project now can get in here, get these documents, modify the documents, use them. There's also a connection on Google Drive, too, so you can connect it to your desktop. So we take a CSV file now, and we can convert it into a database. This took the CSV file and staged it as a MySQL database with a bunch of JavaScript controls. So we can preview the data, we can mark up the data, you can say what the columns are, description, data type, units of measure, and all that kind of thing. And that helps people clean up their spreadsheets and make them understandable. And then I can save this for now in the project area and share it with my project team because we've got a lot of work to do, cleaning up the data and making sure that it looks good. So I'll save this table inside the project, and now it's listed on the databases area. You can see there it is. You can see the CSV file. You can click Update Database if you want to reload the latest data from the CSV, or if anybody wants to access it, you just click that link, and it brings up, again, the latest version of that live interactive database. Now, eventually, we're going to publish that as a digital asset with a digital object identifier that anybody can access. But for now, we got a lot of work to do. So there's a to-do list capability where you can create these little to-do list items, and you can assign them to people on the team. You can give them a due date. You can have conversations about all of this. You can say, hey, I need to clean up the data. Where is the latest data? And I'll say, oh, look in this directory. That's, we need to make sure that that data is incorporated. Double check these fields and so forth. So you can get into threaded conversations here, and eventually we'll check off that to-do list item, and we're ready to publish. And again, all this is being captured on the update wall. You can see all the activity. Even if I didn't put updates up, the system is putting updates up about who joined. and all of that. Now, here's what a published database looks like. Here's a team that went down to Haiti after the earthquake in 2010, and they put their data on nanoHUB at nice.org. And if you go there and search for Haiti earthquake, you can find a bunch of things, including this live database. It's got authors, you can see the project team, you can see a little bit about a description, but if you click Data View, it brings up that live interactive database. I can put in, show me everything greater than 6,000 square feet, and it'll winnow down the buildings to just the big ones, and then I can sort in order of severe concrete damage. And now I'm seeing the biggest buildings that had the most severe damage, and I can even put them on a map to kind of understand what happened in Haiti. So that's kind of a very quick fly-through of what HUBzero is all about. It's lots of sites like that that people are using to create tools and data sets and publish them and make them available for other people in the community to use. All right. Now, I want to focus in and tell you a little bit more. You guys like data, so I want to show you some of the data that we've collected on some of this. The biggest and the oldest hub is nanoHUB. This whole project started with nanoHUB back in 2002, and just for trying to help nanotechnology people share data and tools the way I showed you. nanoHUB now gets 700,000 visitors every year. About 300,000 of them stick around and routinely use the site, so that's our core audience of 300,000 users. And there's lots of stuff, 360 simulation tools that people have uploaded and contributed, and 4,000 other resources. So a lot of stuff, a lot of activity on the hub. And social scientists have kind of found that interesting. They look at nanoHUB as a source of information. It's not as big as Twitter or Facebook, but it's big for science. And there are different things that people have studied. One is, how are people discussing or using nanoHUB in academic literature? So I'll show you a little bit of that. Also, what's the impact of nanoHUB on education and tools in the classroom? And I'll show you a little bit of that. And then finally, think of nanoHUB as a place where you do team science. So we can show you a little bit of that too. So starting with the academic literature, they have a team on nanoHUB that's gone out and scrubbed Google Scholar and found more than 1,100 citations that people have been able to find in the academic literature. And this is kind of the co-authorship citation network. Each of the dots is a paper, and then there's lines between dots as co-authors, right? And they've looked a lot at those papers to figure out what they're about. You can see 80% of them are really research papers. There are some that talk about nanoHUB as a cyber infrastructure and some that talk about its use in education. But the vast majority, 80%, are all about research. And in fact, you'll see things like this. You'll see a group that, for example, measured electrical characteristics of thin films and used a tool on nanoHUB to calibrate their measurements. Or another group that just used a tool on nanoHUB to hypothetically figure out how the next generation of integrated circuits is going to scale going forward. So these are the kinds of things that people are doing, kind of the impact on the academic literature. And there's a lot more drill down, I suppose, that happens in that analysis, but that just gives you a quick overview. Now, I also mentioned education. People put up tools. People use them in classrooms. So for example, instead of copying out of a textbook the night before a lecture, a professor will come into class and just bring up a tool. And a student will have a question, and they'll just pull up a material type, and they'll say, let's see how it works, right? So you can use them in classroom. You can also assign it to students. Let them do the work. Let them optimize a particular electronic device or figure out what material works best. So hands-on or senior design projects kinds of things. And so far, we found about 22,000 students that have used nanoHUB like this in class at about 185 institutions so far. And again, it's interesting to see how we figured that out because surveys aren't really going to cut it. So I have this little video that kind of shows you some of the data. So this is kind of a history of what people are doing on nanoHUB. Each line in this video is a person. So if we look up at one of these lines, think of that as a person. The green dot represents a particular tool, the orange dot represents another tool, and you can see their pattern of activity over time. There's a time when they joined the site and then what they did with various tools. And if you look at all the different users on the site, kind of like this, just dumbly, you can see these correlated patterns of activity. This yellow block here, the green stripe, the purple stripe, those are classes. There's a homework assignment that's due on Friday, and everybody is using the same tool for that. and a different homework assignment the following week, and so forth. And if you just look at this data, it just jumps right out at you that people are using this in coordinated ways. And it turns out we came up with a clustering algorithm and did some more processing and then followed up with people. And sure enough, yeah, they said, yeah, I was part of a chemistry class at Northwestern or whatever. So using this kind of analytics, that's how we've gotten to the numbers. We could figure out, because most people don't tell you they're using it in class. Most professors won't tell you that they're planning to use it or whatever. But by looking at the coordinated patterns, we've been able to kind of figure it out and quantify it. All right, now the really interesting thing, I think, is when we take those two things and put them together. So I imagine if I could figure out for each tool how much it's used in education, and I put that on one axis. And imagine for each tool, I figure out how much it's being used in research, and I put that on another axis. Then I might have a tool, for example, that's being used a lot in education and a little bit in research, or another tool that's being used a little bit in education and a lot in research. And you can kind of see where tools sit in that space. You can, more importantly, follow them over time. So let me show you that. All right, so here is a plot of tools. You can see when a tool is first invented, created, it shows up as a red flash. So a lot of the tools are starting up at the origin. Some start up kind of on the research axis. And you heard a little bit, I showed you earlier, that Rapture toolkit that you could use to drag and drop the controls. As soon as we released that, people started creating tools like crazy. It became a whole lot easier to put tools up on the hub. And you can see the tools really taking off. You also see most of the tools start up on the research axis, but kind of migrate their way into education. And that's really interesting because, you know, if you think about it, it makes perfect sense with the university, the fact that there's so much crossover between education and research, but the research tends to fuel a lot of the educational activities. And that's exactly what we see. At one point, the NSF asked us to classify all the tools at nanoHUB and say which ones were for education and which ones for research. And we didn't know how to answer the question. We do now, because the answer, it's not a clear story, right? It's not a binary education or research. There's a lot of duality and a lot of evolution over time. So that's interesting. All right. Now, just to kind of wind this up, I want to talk a little bit about the collaborative ways that people work together on a hub. And one of the ways that people do that is, for example, when they're working on tools. So you saw earlier, you register a tool project, you get a Subversion repository, and you start working on your tool, trying to get it ready for publication. So imagine, these are all the little teams. Each one of these is a different tool project. And, you know, some projects maybe just a single developer, some have a few or three. I think typically, some have 10. You'll typically see a team size of about 3 to 5 people working on a little software tool like this on nanoHUB. Now imagine for a second, every time they touch the source code and check it into Subversion, imagine you see the tool kind of wiggling around a little bit. And you'll see this in a minute. And imagine too, as they're walking through the states, you know, you register a tool, you get a tool created, uploaded, it finally gets installed, you approve it, it gets published, and at some point you might even retire the tool. So there's this life cycle to the tool, and every time a tool changes state, in a minute you'll see a line kind of coming out from nanoHUB to the tool, kind of indicating that we're working, there's a handoff there, that we're working with them to kind of help the tool change state. And the goal is to get all these tools to green. But some tools, they're bug fixes, and they go backwards, and they go all the way back to green again, they go back and up to green again. And some tools get improved over time, and you'll see a lot of activity. So let me show you kind of a year in the life of nanoHUB and all these different tool projects that are happening. I think there's about 700 projects that you'll see here. And again, each of these dots is a tool project. So each dot is a separate tool. And the goal is to get all the tools to the green state, because that means they're published. You can see them appearing around the outside rim here. You can see them shaking around as the developers are checking in code into Subversion. And every time a line comes out, there's a state change. The state change from gray to blue to green and so forth. You can see a couple of retired tools as well. You can see over the summer, there's a huge amount of activity. We typically have summer students come in, REUs and so forth, and they create all kinds of tool projects. We do some training. You can see some tools just languish. They get started, but they never finish. And others kind of go through the state multiple times. In fact, even the old tools get updated and republished over time. So this is what it looks like in terms of nanoHUB interacting with the community as new tools come online and people do development. Now, the really interesting thing is inside each one of these dots, each one is a little project with like 3 or 5 developers, and there's dynamics that are happening inside there in terms of how the developers interact. So that kind of gives you the big picture, but the next thing, we drilled down a little bit. I say we, it was actually Nosh Contractor who got the idea. He wanted to see how people were interacting on nanoHUB. So Nosh Contractor is a professor at Northwestern University. He got the data set from nanoHUB and started studying the team dynamics in each one of those little dots. And he presented this, by the way, if you look up HUBzero 2012, he gave a keynote and presented this talk on some assembly required, self-organizing teams and their performance. But just to kind of paraphrase him a little bit, out of the talk, he found a few interesting things. One was that teams had more success if, for example, they had many versions. So if you improved a tool, you didn't just put it up once, but you fixed it, you improved it, you added features. The more versions you had, typically the better your ratings. It correlated with good ratings of the tool because the tool was fresh and well supported. That makes sense. He also found that if the tools were open source and if they included authors from different universities, they tended to get more citations. So if you want to get paid, if you want to do well, make your stuff open source. Make sure you have other people from different universities, hopefully all around the world. Because if you do that, you'll just tend to get more citations, period. And I guess it's interesting to think of why. It may be that these guys and their friends are all citing you, I don't know. But somehow by kind of seeding your collaborations out into the world, it tends to give you more success that way. And then along the axis of users, again, if you had authors from different countries, and again, if you had many different versions, then you would tend to get more users. So the tools with the most users had that kind of diversity. And if you put it all together, if you follow all of these strategies, you'll tend to get good ratings, more citations, and more users, which overall gives you success. Nosh has a really interesting paper. I forgot to put the reference on here, but it's called Moneyball for nanoHUB or something. It's basically, the movie Moneyball where they tried to figure out the best baseball team, not by getting the star players, but by getting what they needed on the team, right? So he has a whole paper. If you Google Moneyball and Nosh Contractor, it'll come up, and it's a really interesting read. It's exactly this kind of theory. So just to mention, I talked a lot about nanoHUB, but again, nanoHUB is one of about 60 hubs. So just to mention some of the other hubs that are out there, again, the one on earthquake engineering where they shake up buildings and try to see how they fall apart. There's pharmaceutical manufacturing where they're working on how to manufacture different kinds of powders and pills and capsules. Molecular diagnostics is one where they're disease agents and they're using molecular diagnostics. Environmental modeling, volcanology. There's one for cancer care. There's a new one we started recently for the NIH, for the National Cancer Institute. It's pretty small now. It hasn't quite reached some of these. It's just started. So anyway, lots of different hubs, lots of different kinds of communities. Everything, HUBzero is human-animal relationships like seeing eye dogs. There are some that involve education. This one's data management. So really spans the gamut of different science contexts. And that's it. That's the nickel tour of HUBzero. I hope it gave you some ideas about what it is and how people are using it. If you're interested, there are lots of hubs out there to study. I think there's a ton of data that nobody is looking at. It's kind of sad that we do all of this and generate all this data, and it's not really being analyzed very well just by a few people like Nosh Contractor. And so opportunities to jump in, and if you're trying to create this kind of infrastructure, again, the software is free, open source, you can download it, set it up on your own servers. We even have an Amazon Web Services image that you can use to start up a hub too. So I'm happy to take any questions. There's not a data science or a network science hub. I was always hoping that we'd get you guys to be the first, but maybe yet to be determined. So there's a wide open area there. Yeah?
You provided using the software, but the hubs are stored and components of that.
Yeah, the question is about the hosting. So we actually do all of that. So we provide, for example, the software stack, and some people take it and set up a hub at their local institution, Washington State University, University of Illinois, whatever. Some people do that. Some people say, look, I don't want to mess with it. You guys host it for me. So we also offer hosting services. We got about 25 hubs that we host at Purdue for lots of different people, for SUNY Buffalo, for NIH, EPA, all kinds of different agencies, and of course Purdue. And then we also have a HUBzero Foundation set up. So for people that are running the open source software and that need a little bit of help, they can buy into this HUBzero Foundation, and it gives them tech support. It's only $5K to join, and it gives you like 20 hours of instant online chat kind of tech support that you can access. And you can pay as you go if you need more support and all of that. So there's a variety of things. There's a few companies out there too. There's No Innovation, a company called In3 Applications, and also BioTeam that all provide HUBzero either hosting or consulting services for different organizations. So for me, the more people using it, the better. And I'm happy to have all these other companies kind of pick it up and use it.
How long does it typically take for you to start up an instance? Like for an nanoHUB, or is it just you need to see that the adoption rate works?
Yeah. Yeah, it's a really great question because, one reason, too, we call it a hub instead of a website is that you have to build a community. It's not just about putting the website up because the website goes up in 5 minutes if you use the Amazon instance. But then you got to get data uploaded. You got to fill it with content. You got to keep filling it with content. You got to feed the machine, and then the users come. A typical kind of thing is that at the end of a year, you probably have 1,000 users. And then from there on, it should double every 12 to 18 months. So it typically doubles, and it's like a Moore's Law kind of thing where it's 12 to 18. The nanoHUB actually grew faster than that, so they beat those numbers and doubled faster and grew faster in their first year. But a very typical pattern is after a year to have 1,000 and then just double after that if you're doing everything right. If you're not doubling, you're doing something wrong. You're either not putting up content, it's not well advertised, the site's down, something's wrong if it's not doubling. Yeah.
As far as tool development, do you feel like you evolved with the technologies, web technologies like HTML5 and JavaScript that
Yeah, great question, because we've been doing this for like 12 years now or something, so there's a lot of history in the package. But for example, what we have on the back end right now is OpenVZ containers. That's the reason we can let people upload their code, because we don't trust their code. We run it in secure containers that wall them off from everything else. So we've got OpenVZ containers running in the back end. We're running the latest VNC, Tiger VNC, and we used to have a Java connector for the remote desktop, but we actually have a JavaScript one now. So we can support, if you go to HUBzero.org today, it's installed there, and you can actually run the tools on your iPad or your iPhone, and we're gradually rolling it out to all of our hosted hubs and making it part of the package as we're testing right now. So yeah, with HTML5 for the client, we have that. Of course, for the web technology, I think we do a super job keeping up there. On the back end, we're kind of looking at Docker right now, because Docker might be a replacement for OpenVZ, but so far haven't gone there. We're also looking, we've got a Moonshot rack from HP. HP has a Moonshot chassis where you can get lots of different computers, and the neat thing there is that you can buy small, cheap CPUs with graphics. So you can basically give lots of users their own graphics card. Because if you're doing high-powered visualization, you kind of need a way to inexpensively give everybody their graphics card. So we're actually investigating the Moonshot thing right now. And a lot of the work we do, too, in terms of security, trying to keep the site, all these sites secure, because we have 2 running HIPAA now, and we're doing FISMA for NIH, and there's a big security focus to make sure everything's running. So yeah, a lot of stuff happening all the time. The one good thing I like about this project is that whenever we make an improvement, it actually benefits all the hubs. When I started at Purdue, there were all these groups that were all doing their own thing, and there was no common thread tying them all together. But with HUBzero, we actually have lots of, it's not just me. I have colleagues at RCAC that write proposals that build on HUBzero that I think is terrific, because that gives us a stronger core that everybody benefits from. So. Yeah. Sure, thank you. Thanks for having me.